Now, since we are interested in fluids, because a lot of manufacturing processes are performed with materials in the fluid state, we should define what are the main properties of fluids. And viscosity is one of the main fluids properties. If you have taken fluid mechanics, you will be familiar with it. If not, it's not a problem. You will see it. We will see the definition of viscosity together. So viscosity is the resistance to flow that is characteristic of a given fluid. Okay, so it will try to oppose variation of velocity inside the fluid. Flow is a defining characteristic of fluids, but the tendency to flow will vary for different fluids. Okay, so for example, you can take example of mercury. Mercury is one of the highly viscous fluids. Okay, while, for example, water has relatively a low viscosity because it's easier. Yani, try to pour the content of water or the content of mercury. It will be easier to pour water than mercury. Okay. So viscosity is a measure of the internal friction when velocity gradients are present in the fluid. The more viscous the fluid, the higher will be the internal friction and the greater will be the resistance to flow. And the reciprocal of viscosity is fluidity. Okay. Now, let us see how to define viscosity. Uh, a typical way to define viscosity is to consider two plates, one fixed, one moving, and you have a fluid in between. Okay, so since what is happening here, you have the lower plate is fixed, okay, while the upper plate is in motion. So this will create, if you want, a variation in velocity in your fluid, because whenever you have a viscous flow, okay, you have from fluids what is called the no slip condition. What do we mean by the no slip condition? This means that a liquid, a viscous liquid that is in contact with a surface, okay, will have the same velocity of the surface. So here at the contact with the fixed plate, the velocity is imposed to be zero. And at the contact with the moving plate, the velocity is imposed to have a certain positive value v. So what will happen? You are forcing a change in velocity in your fluid. Now the viscosity is the resistance to this variation. Okay, so higher the viscosity, higher will be the resistance to velocity change. Okay, and we can define, if you want here, the rate of velocity variation is dv over dy. Okay, and we will see together that we can correlate the shear stress applied to the variation, the rate of variation of velocity with y. And the exponent relating them will be the viscosity. So here, first we will define the shear stress. The shear stress will be the frictional force exerted by the fluid per unit area. So here, whenever you want to impose a certain velocity, you will apply a certain force. By applying a force on the plate and dividing by the corresponding area, you can get the value of the shear stress applied, that is applied on the fluid. Okay, because at the end, this force will be transmitted to the fluid at the contact between the plate and the fluid. Okay, so the shear is defined as the ratio of the applied force on the fluid over its area, and the shear rate is defined as dv by dy. Okay, so here it's gamma if you want. This is gamma. Gamma is dv over dy. Gamma is the shear rate. dv is a change in velocity for a certain variation in distance dy. Okay. Now, the shear rate is defined as the velocity gradient perpendicular to flow direction. Now we will see that the viscosity will be included as it will relate the shear force, okay, to the shear rate. So we have observed that experimentally that the relationship between the shear stress and the shear rate will be depending on the viscosity of the material. Okay, so N is a constant of proportionality called the coefficient of viscosity. Now, this viscosity can be constant or variable. So for Newtonian fluids, the shear viscosity is constant, while for non-Newtonian fluids, it's variable. And we will see the behavior of different materials to see for which one we have constant viscosity and for which one the viscosity is variable. Okay. Now, so if we rearrange the terms, we can say that the viscosity is simply defined as the shear stress over the shear rate, okay, where the shear rate is dV over dy. So, and in general, the viscosity is measured experimentally. So the viscosity of a fluid is the ratio of the shear stress to the shear rate during the flow. Now, flow rate and viscosity of polymers. So in general, viscosity of a thermoplastic polymer is not constant. So we cannot say that it's a Newtonian fluid. Okay, it will be affected by the flow rate, and its behavior is non-Newtonian. A fluid that exhibits this decreasing viscosity with increasing shear rate is called pseudoplastic. Okay, so we will have different behaviors. Some materials, okay, will have increased velocity with increasing shear rate, while others will have decreasing viscosity with increasing shear rate. Next time we will see in detail the different possible behavior and what are the typical materials for each one. Just for now, you should know that viscosity can be constant in the case of Newtonian fluids, and it is not constant for other non-Newtonian fluids. And we have, for non-Newtonian fluids, we have several possibilities. We have pseudoplastic, and we have much other. So you can see them here in the graph. Next time, we will detail the different behaviors. Okay? Thank you. Any question on this? So see you next time. Bye-bye.